Earthquakes, they happen and they cause damage, destruction, and death. What is the reason for earthquakes? It is about tectonic movements and the earth crust moving. But today we're going to talk about how buildings respond to earthquakes. Now, buildings are today built as buildings which are earthquake resilient, are earthquake safe. But if you look at the history, there were many earthquakes that were built, that happened to buildings which were earthquake resilient buildings, and the buildings collapsed. Now, this was very much true, in the 1995 Kobe earthquake and the Kochueli earthquake in 1995 and the Niigataken Kyoto earthquake in 2004. In this, despite being earthquake resistant design, the buildings were damaged, structures were damaged. So what is the solution to this problem? The solution is very simple. We make the full building and then we test that building by creating an earthquake to see how the building is going to react. And that is only possible with a thing called a 3D shake table. Now you can make a small model of a building and then shake that. But the small model, even with the materials, even with the structure, will miss out on certain things because small scale context cannot capture the dynamic non-linearities with accuracy. That is why large scale is important. Number two, apart from the large scale that is important to create, it is very difficult to have recreation of the earthquake. So you need large forces generated by some kind of a mechanism which can generate that earthquake. So in the world we have a lot of numerical models, but they are inaccurate because we had earthquakes which were actually destroying a lot of the buildings which were designed to be earthquake resistant. So what do we do? Even when we have numerical models, computer simulations, we, as I said before, make real buildings and test them for real earthquakes in buildings which are called shake tables. And in this video I'm going to talk about the world's largest 3D shake table which I visited, and which is called eDefense, or the National Research Institute for Earth Science and Disaster Resilience, and the center is called Hyogo Earthquake Engineering Research Center. This particular building is in Miki-shi. This is in the Hyogo prefecture and it's called eDefense. This has a Guinness record, as I said before, of the largest 3D earthquake, shake table. This is open to the world. All scientists can go. Facts about it. That in 1995, when there was Kobe earthquake, 6,500 people lost their lives and there was a loss to property of over 100 billion. This led to, a lot of reaction. So the government said that we will research and make buildings which are earthquake safe. So they made world's largest 3D shake table. This is a 20 meter by 15 meter shake table. Dynamic collapse test of structures it can do, and this can take weights of over 200 ton F, and it is itself 770 ton by weight. Now if you look at this, I went there, a very kind gentleman gave me a lift. It is in Miki-shi. I had to go travel in a bullet train, then take another train, then finally reach this place. And a person gave me a lift to the center, which is above in the mountains top, kind of little away from cities, because testing has to be done there. A lot of work is being done there for drills for what happens when you do an earthquake. So there's a center for that, but the main focus is this building, which is having these multiple buildings.
So this one is the main center where experiments happen. This is the exhibition hall where we are. This is where the models are prepared and then they are taken inside through this gate, which we just saw. At the back, this one being the experiment room, this one is the model preparing room, this one is the engine room and the accumulator room. So hydraulic system pumps a lot of fluid into the actuators located inside this where they move the shake table, and models prepared here are taken inside. There are two high capacity cranes which lift the models onto the shake table, and that shakes the model, and then results are taken in a control unit.
Buildings, and there's this big thing, and a person took me, a very nice gentleman took me around. He was speaking in Japanese because the tour is only available in Japanese.
ここへはどうして来られました？タクシー？
Bus.
バス？
I came here on lift.
リフト？4台、4300馬力、4300馬力のエンジンが4台あります。でこのエンジンを動かせて、隣のアキュムレーターに圧力を蓄えます。200気圧ってでその圧力を使って先ほどの過信機を振動台を動かすんですね。
But I could later figure out using YouTube videos that what the whole thing is all about. And then thanks to this kind lady, Mami Tanabe-san, who gave me the permission, because you have to apply for a permission. There's an application form that you have to fill, and then you can go there and visit. So it's a 1-hour tour, and I had to wear this helmet and go inside and see this. Now, it's important to see that these structures are very rare in the world. There is an international federation kind of a structure where all the scientists can use structures like testing methods like this. So it's a good idea that we also have something like that at the scale in India, because we've also had terrible earthquakes. I have childhood memories of 2001 earthquake. I heard in news that there was a Bhuj earthquake. So if we could also have buildings tested live, against earthquakes. So this particular building, this shake table, does in x-axis, y-axis and z-axis. And the x-axis, it can take maximum acceleration x and y 900 centimeter per second square. In the z, because it has 14 of such actuators, it can take 1500 centimeter per second square. Maximum velocity in x and y is 200 centimeter per second, and for the z it is 70. Maximum displacement plus minus 100 centimeter for x and y and 70 centimeter for z. Maximum allowable moment, overturning happens in x and y 1500 mn meter, and y-axis 400 mn meter. So this is something about this shake table. For everybody who's into structures, architecture, you have to see what is a shake table. You have to see how buildings are tested, and even with your best of your design that you do, there are vulnerabilities built in buildings, and they have to be tested in real scales. This was about the world's largest shake table for you. Thank you so much. You please like, subscribe and share. It's very important that you subscribe so that you keep getting quality videos. Thank you very much.